In this question, it is given a block of mass m is kept on this conveyor belt which is moving with a constant velocity v0. The coefficient of static friction is mu s between these two, and the coefficient of kinetic friction is mu k between these two. The acceleration of gravity is given to me as small g. Initially, this object slips on this conveyor belt, and finally it starts moving without any slipping. So the question follows: how far the conveyor belt moves while the object is sleeping? Means for the time period when this object is sleeping, we have to find this displacement of this conveyor belt, that how much it has moved. So let's see the solution. Look over here, I have drawn the FBD of this block in the frame of this conveyor belt. As this conveyor belt is moving with a constant velocity, there will be no pseudo force acting on it. There will be a normal reaction upward and mg acting downward. The kinetic friction will be acting in this forward direction because this block will going to slip in backward direction with respect to this conveyor belt. So this is the FBD of this block. Now from here I can write the value of A in the frame of conveyor belt. It will be Fk upon m. Now the value of Fk will be mu k into n, and n is equals to mg. It is clearly visible, n is equals to mg. So I can write mu k into mg upon m. So it will come out to be mu k into g. Now this is my value of acceleration in the frame of this conveyor belt. Now finally these two are moving without slipping, means v relative will be 0. This is the final relative velocity, it will be 0. So in this frame of conveyor belt I can write final velocity will be 0. Initially this block was kept, so the velocity of block with respect to ground was 0. So velocity of block with respect to this conveyor belt will be 0 minus v0. That is the velocity of conveyor belt, it will be minus v0. So I can write final velocity as 0, initial velocity will be minus v0, plus acceleration I find it as mu k into g into t. From here the value of t will come out to be v0 upon mu k into g. This is my equation number 2. Means for this time period this block will going to slip. Now I can find the displacement of conveyor belt. It will be velocity of conveyor belt into time. Now time I have calculated. What is the value of time? It is v0 into mu kg. So it will be v0 square upon mu kg, which is in option A. So my correct answer is option A, v0 square upon mu kg. Okay. Now in the second question, what it is saying: the work done on the object by friction force relative to the reference frame moving with the conveyor belt is, means in the frame of this conveyor belt we have to find the work done by the friction force. So let's see what I can write. I can write the change in kinetic energy with respect to conveyor belt will be equals to work done by normal plus work done by gravity plus work done by friction. Okay, now work done by normal and gravity is 0. Why? Because displacement is in perpendicular direction to these forces. So I can write the change in kinetic energy with respect to conveyor belt will be work done by friction force. I've used the work energy theorem over here. Now kinetic energy initial in conveyor belt reference frame will be minus v0 square into half into m, half m minus v0 square, and kinetic energy final in conveyor belt frame will be 0 because they both start moving with the same velocity. So the relative velocity will be 0. From these two I can write change in kinetic energy with respect to conveyor belt will be kinetic energy final, that is 0, minus kinetic energy initial, that is minus half m v0 square. Okay, so work done by friction will be change in kinetic energy, and these both are in frame of conveyor belt. So work done by friction in conveyor belt frame will come out to be minus half m v0 square, which is given which is given in option B. So my option B is correct for this question. I hope you have understood this. Thank you very much.